All right, I think now would be a good time to get started. So I'm Hazel Tomlin, one of the co-leads of the GRA Inventories and NDC network. And I'd like to welcome you all to the third webinar that we've had in 2022 on commissioning and managing agricultural research projects and for the inventory. So this session will build on the first two sessions that we've had. The first was on the policy relevance of inventories for agriculture mitigation, and the second on data challenges that are faced when estimating emissions at the national inventory level. So this one will discuss kind of the process around designing research projects to improve emission estimates, the policies they inform, and provide some examples from our speakers and the countries that they've worked in. And I would like to note the difference between Q&A and the chat. So please express your questions in the Q&A function, and you can ask those questions either directly to one speaker or to all speakers, and use the chat function to kind of make comments or to introduce yourself to colleagues. So finally, I would like to introduce our chair, Dr. Claudia Arndt. She's senior scientist and co-leader of ILRI's Mazingira Centre in Kenya. And we're really lucky to have her chair the session today. She does bring a very international perspective, being originally from Germany, having studied her PhD in the USA, and having worked for a number of years in Peru and Costa Rica before her current position in Kenya. So we're grateful for that. With that, Claudia, I shall hand over to you.
Thank you very much, Hazel. Welcome everybody for today's webinar. And with that, I would like to introduce our first speaker, Joel Gibbs. He is the Agriculture Greenhouse Gas Inventory Team Leader in New Zealand and directs the National Inventory Research Procurement Process. For several years, Joel has been increasing the visibility of the New Zealand inventory research needs and established strong research relationships with the national and international greenhouse gas science community. He has secured funding for national and multilateral research projects with countries with similar agricultural production to New Zealand. He subsequently led the incorporation of many recommended changes to improve the accuracy of New Zealand's emission estimates. He's also a qualified UNFCCC expert inventory reviewer and has participated in several international reviews. And with that, I would like to have Joel present his presentation on commissioning and managing agriculture inventory research and projects.
Cool, thanks for that introduction, Claudia. Just speak out if you can't see the slides on the screen.
Everything is there, perfect.
Oh, cool,
no
thanks. As mentioned, I will be speaking about my experiences in commissioning and managing greenhouse gas research projects, and then using that research to improve emissions reporting for New Zealand. I will be covering off the identification and prioritisation of suitable research topics, the commissioning and design of research and contracts, and the implementation of that new research into inventories, and then I will close off with some examples from earlier work. The overall purpose of commissioning research is to improve the accuracy of emissions estimates, or to get a better understanding of emissions uncertainty. And the notes here, I should say this, are based on my experiences only. And so other people from other countries will have their own observations and experiences based off their situations and the rules around how they procure research and the resources that they have. And I should note that in some cases, New Zealand is fortunate relative to some other countries in this regard, in terms of its resources available for research. But it's also quite an insular experience because we're so isolated from other countries, we aren't able to build off some of the research done in other countries to the extent that other countries are able to. I think most inventory compilers will be fairly competent or experienced in identifying new research topics by using the existing tools like key category analysis, or going off the review experts from international experts, and looking at the sources of uncertainty for the inventories. But there are some other things to consider when identifying research topics, and some of those are holding research workshops and conferences with experts to identify new research topics, and looking at how long since research in a particular area was done. And there's a particular temptation to avoid looking at a relatively minor source of emissions because it's minor, despite it being reviewed in a long time. When designing the research, I've found it's important to have really clear and unambiguous requirements in the commissioning of the research and in the wording of the research contracts when they're set up. And making sure that the outcomes of the research have really clear recommendations for the inventory improvements, unless the work is intended or has the purpose of just being exploratory. Researchers I've found can sometimes be hesitant to do this, but even a research conclusion that says the current emission factor or method is still appropriate, or even a recommendation that says there is not enough evidence to recommend a change is still good. So that comes down to just in the wording of the contract, making sure that one of the outcomes is a clear statement or recommendation for a revised emission factor or method. In terms of other things around designing the research or designing the research contract, it's also worth considering setting aside resource for an independent peer review, particularly if a significant change is being proposed. And so that's something you can work with the researchers on, or arrange yourself depending on the topic and who you know in the area that could be that independent review person. It's also quite useful sometimes to arrange for the researchers to also write an article on their research for a journal. It just gives the work a lot more legitimacy, particularly once you're at the stage of implementing that new change into the inventory. Having the ability to point to the work being recognised in a peer-reviewed journal is really useful. And then finally, also worth considering if there are new emission factors, submitting them to the relevant databases, such as the emission factor database, or some of the other ones managed by other organisations. Some research that's done for particular topics can have significant implications for the reported emissions of a country. For example, a new emission factor that is significantly different to the current emission factor. These significant inventory improvements will likely be reviewed more thoroughly by expert review teams. And so in that case, there is obviously a need to ensure that the justification for that change is backed up by strong evidence and research. And it's also, for some cases, worth considering having a group of experts to review and advise on any change that is being proposed, and having an audit trail or paper trail of this as well, just to back up and get a surety of the change that's being proposed and making sure that that the case for making the change is really strong. I'm going to go into a couple of examples of research in New Zealand's case that led to inventory improvements in recent times. The first one is a relatively small change on the purity of agricultural lime. So prior to this research, we had assumed that the agricultural lime used in New Zealand was just 100% pure. However, we commissioned some research in 2020, and which found that the lime that was mined and used in New Zealand was not 100% pure lime. And so that research was completed in 2020, and then we incorporated that into the New Zealand inventory this year. And so that was associated with a research project, independent peer review, and also advice from an independent panel of experts. So that was a relatively straightforward piece of research that resulted in inventory improvements. The second example I've got there is N2O emission factors for different hill slopes. This was quite a big piece of work that required 3 separate pieces of research over a number of years, 2 field studies and then 1 desk-based study. And the reason why it required so many research projects and so long was the complexity of the work and the fact that our independent panel that advised on this told us to go back or advised us to go back and get more information and data to justify that change more thoroughly. Some inventory, so this shows that some research projects can be incorporated directly into inventories, while other improvements require multiple projects. And that might be both field-based measurements, like direct measurements of emission factors, or it might be also research just desk-based as well. And then my key messages, my final key messages are, it's important to have really clear and unambiguous requirements in the commissioning of research, and to make sure that the outcomes of the research will have clear recommendations for changes or non-changes if that's what the researchers find. And it's also important to set aside resource for an independent peer review. And also just the understanding that some research or some improvements will require multiple pieces of research if they're particularly complex. And then other smaller changes might only need just one simple project. And those are all my slides. Thank you for your time, and I look forward to your questions or comments.
Thank you very much, Joel. Thank you for doing so well with the time. I'm opening the floor for some questions. So if you have a question, I don't know if people can raise their hands as well.
Not possible, I think, to raise hands, and also not possible to actually speak a question. But feel free to put any questions in the chat.
Okay, so while we're waiting for questions, I was wondering if you could give an example of research that actually wasn't well thought and could in the end not give a recommendation to the inventory and a successful project, maybe, just to show the difference that others don't run into the trap that they do research, which in the end cannot be used.
Yeah.
Do you have such a
I do have an example from a New Zealand context. So a few years ago, we were looking at improving our inventory for goats. So at the moment, New Zealand has a tier 1 methodology for goats with some country-specific values for certain areas. We were wanting to improve that inventory and also incorporate differences for dairy goats versus goats that are farmed for meat. We commissioned some research, and a proposed methodology was included in that new research, but it was ultimately not recommended for inclusion in our inventory from our independent panel due to concerns about the consistency of the research, particularly around things like manure management and some concerns around some of the values not looking to be consistent with the normal dairy goat operations that occur in New Zealand. And so ultimately we decided not to go ahead with that proposed methodology. And I think what sort of hindered that work was the lack of a thorough independent peer review during the project itself. And then possibly also a lack of a thorough review from the inventory team ourselves during that project. Yeah. And another example being the N2O hill country research that I mentioned previously. At least in the initial stages, the good thing about that though was that we were able to commission additional research to get additional measurements that were recommended by our panel to fill in the gaps as well. So just because something is a failure, it doesn't mean it has to. You have to throw it out entirely. It may just mean that you need to do more field measurements in different seasons or different areas of the country to make it more robust.
Okay, thank you very much. I've got two questions for you, but we need to have an answer short. One from Goni. Is the review by the journal enough, or do we need an independent review in addition? And then I'm summarizing the second one as well from Maggie. How do you select the external peer reviewers?
Okay, the first question. It depends whether having both is necessary. It depends on the research itself, and it depends on what. It depends on your own judgment, I think. Sometimes having both is quite useful. I know sometimes with the journal article, it takes quite a bit of time to get those articles published and included in the journals. So in that case, it might be good to have that independent peer review done first as well, and also that aids with getting that journal article published as well. But yeah, it depends. And then the second question, could you just remind me quickly what it was?
How you select the reviewers.
Oh yes. In the past, we've found that the researchers themselves have a pretty good idea of the other experts involved in this area, and so they can often provide suggestions for that. But often once you've worked in this area long enough, you'll develop a network of experts that you can often refer to repeatedly. Yeah.
Thank you very much. I assume that if someone has questions, they could reach out to you if they're looking for a reviewer.
Yeah.
Okay, great. Thank you very much. With that, I would like to move on to our next presenter, Sana in Taiwan. She's an international consultant and AFOLO MRV specialist. She has previously led the Mongolia's AFOLO inventory team and the development of the Tier 2 livestock inventory that will be used in Mongolia's next national submission. Her specific expertise is on agricultural policies and measurements, mitigation actions and their effects, projections of greenhouse gas emissions and research, and systematic observations for the AFOLO inventory. Sana is also a qualified UNFCCC expert reviewer and has participated in several international inventory reviews. Sana is currently based in Switzerland and consulting on related international projects. And she will today talk about the experience and lessons learned from agricultural projects. And with that, you see her presentation. It looks good. I give the floor to Sana.
Okay. Hello, everyone. Thank you, Claudia, for introduction. So, as she said, I would like to share my private experience and lessons during the involvement of the implemented agriculture and Afolo sector projects in Mongolia. I was working in the climate change office, firstly as a joint credit mechanism between Japan and Mongolia. This is a carbon market mechanism, and as a secretariat. And after that, I shifted to the inventory team, and my responsible sector was the Afolo sector. And I contributed the reports of initial BUR report and national inventory report, as well as and third national communication. During this report development, several projects, international and bilateral and multilateral projects implemented in Mongolia, and I involved. And within this, most closely related to today's topic is a RED Plus. And in a RED Plus, our team was using the collective assessment to determine the land use change in Mongolia for 30 years, over the 100,000 plots. And next one is the Japanese government project, which named it the Project for Capacity Development to establish a national GHG inventory cycle of continuous improvement. And two sectors was selected. One was energy, and another one was Afolo. Within the Afolo sector, the focus was topic was focused on the grassland soil and biomass study in Mongolia. And then the next and the currently implementing, and it's the last stage of implementation, is the CBIT project. Most of you heard about this project. And CBIT project has national and global CBIT project, and national CBIT capacity building and transparency project is implemented from 2018 from Mongolia. And it's it covers the emission factors, activity data, quality assurance and quality control protocol, metadata, and institutional arrangement improvement and capacity building, and many more, and adaptation mitigation and inventory. Everything is included in the framework of this project. So based on this, it's again, it's on my personal perspective, and maybe not official official thoughts from the Mongolian or any other developing country's perspective. Maybe it's different for people. And in general, the beginning of the project stage, the pre-assessment is done, like all of the projects, the interviews, gap analysis, capacity and institutional arrangements. Also, the different from the other project is the inventory project is mainly broadly based on the improvement plan, because every inventory report has an improvement plan section, and it's included like how the next submission or next subsequent submission plan in this country, the key category or high uncertainty categories are not estimated emission estimation, how will be improved like this. And so CBIT project also on the I will talk about the example of livestock emission factor research of the CBIT project, not other activities. And so it's a mainly based the key category improvement plan, and also the gap analysis, and the besides to develop the tier 2 emission factor study on cattle, sheep, and goat. And there was conducted several measurements, like a live weight measurement, also the feed measurement, manure measurement study was conducted. But as you see from this screen, there's a number of the animals covered by the study for the live weight measurement. And below this, the total livestock number of Mongolia by 2021. And we have now almost 67 million animals, and within these, cattle about 5 million, sheep over 30 million, goats 26 million, and in 21 provinces. So from the as I observed the sectoral improvement keynotes in the beginning of the project is a sectoral improvement plan of the GHG inventory report should detail as much as possible, because the last submission, for example, I did the improvement plan, and now I think it was too raw, and when possible, the inventory compiler should detailed plan included in the inventory. Then it's and next time the new project or new activity will be clearly aimed. And also definitely there are no unlimited funding or timing, but sometimes the research scale and timing is purely dependent on the funding available, and sometimes not enough for the study requirement. And here I refer this funding is a purely devoted budget for the research activity, not included the management part or something that is and unfortunately some good project is, but limited time is scaled, and especially for the affordable sector, agriculture, forest study, and it's better long-term or sequential studies is necessary. Okay, during the implementation of the project, this CBIT project, for example, has under the GF Food and Agriculture Organization, and under this project management unit is established, and plus the project steering committee was established ad hoc basis, and project management unit is making on mainly the contracting, procurement, receiving the some results and reporting to the FAO and the upper level and ministry level. And for the research side, for the cattle, the enteric fermentation emission factor estimation is conducted for the cattle. But some of the measurements and field study was delayed due to the COVID in the last 2 years. And so some estimation is based on the previously made studies, not during this project. But important, but a good lesson was the most relevant stakeholders was participated and contracted officially. So through this official contract and official involvement, the awareness and interest of the other related stakeholders was improved a lot. And, addition to the training, but sometimes training is some people come and go, and But with this official letter of agreement or official contract, more responsible and more closer involvement was provided. And in general, also this win-win collaboration should be aimed in the inventory project, because mostly the other organizations not interested because cannot see or not explain it or not provided the information how and their organization is beneficial from this improved inventory data or information. So these are always keep in mind, should be. And the procurement based on study design and assessment plan is crucial, especially not selecting the personnel or team quality selection is sometimes not so beneficial, because before they make a contract should like a bidding process, statistically sound the study complete design, and if it's not the measurement, the assessment plan, and what kind of data exactly will be collected should be informed and good negotiated is to save the source, and timing is very important. And the last one is the shuffle activity sequence between countries. This is just an idea, maybe if possible, for example, the similar countries with the similar natural resource, climate condition, or livestock herd structure could be, for example, in Mongolia, maybe only focus on the sheep study, and maybe next country's goat study or something, or manure management or interference. This kind of shuffling maybe to exchange the experience before the too much time and resource consuming. Or in the within the country regions, if it's impossible to independently do the projects, then it's maybe the shuffling activities is good, probably. And this is my last slide, and the result application and the dissemination in Mongolia. Under the besides the ministry, there is a science and technology committee of Ministry of Environment and Tourism of Mongolia, and this is a ad hoc basis. And so something like emission factor or this kind of new improvement of the study applied to the official reporting should be approved by this committee. And this as mentioned, these cattle new emission factors and disaggregation between cattle and yak new factor estimated factors is now under the planning and planning to include in the second BOR. And most most projects, it's just final workshops, brochures, and some with the different qualified reports, and then it's finished. But after this lots of work and efforts, the dissemination and this final results and this publicity is very important, same as the main research activity. And this approval of this committee is okay, one kind of approval, but the as much as possible, this peer-reviewed publication is really good contribution to the improvement of the greenhouse gas inventory reporting and the next mitigation activities. And in the end, this inventory results are a very important starting point for the next projects and measures, and the most narrowed and basic information, and to bring the new projects and activities in the future. And thank you very much for your kind attention.
Thank you so much, Sana. Looking at the time, I will keep questions for you for later. I hope that's okay with
sorry.
you. And
Yeah,
no,
sorry.
it's okay. Thank you. This is a good presentation. We all enjoyed it. So I would like to introduce Heinz Flesser. He is the director of the Thunen Institute in Germany, and has previously directed Thunen Institute of Agriculture and Climate Research. Through his research as a temperate and boreal soil scientist, Heinz has worked for several years alongside the German inventory team and was one of the lead contributors to Germany's first national soil inventory. His research interests include carbon and nitrogen dynamics in soil, soils as a source and sink of greenhouse gases, the effects of land use and climate change on element dynamics in terrestrial ecosystems, and stable isotopes and biochemical research. Heinz has also led the coordination of and contributed to several research projects related to climate projections in agriculture, the effect of land use, management, and site conditions on greenhouse gas emissions, and controls of carbon and nitrogen dynamics in soil. And he is today presenting to us new methods of nitrous oxide emission reporting in Germany. With that, I give the floor to Heinz.
Thank you for the kind introduction. I try to share my screen and start the presentation. Oh, it doesn't run.
Yeah, it doesn't want to.
Okay, so it should work.
No,
Just
it's there. It's there.
It's fine.
Yeah, it's good now.
Okay. Yeah. Hello, everyone. I like to give a practical example how we in Germany try to improve our reporting system with respect to direct N2O emission from fertilized soils. And the data I will present were recently published in Agriculture Ecosystem and Environment, new N2O emission factors for crop residues and fertilizer inputs to agricultural soils in Germany. And most of the work was done by the first guys here, by Roland Fuß and Gokul Prasad, but both are on holiday, and so they asked me to take over and present the results. Why is Germany in particular interested in nitrous oxide emission and improvement of reporting with respect to nitrous oxide is easy to understand if you look at these figures. So about 80% of the total national N2O emission originates from agriculture, and within agriculture, fertilized soils are the main source. And if you look at the right-hand side here to the total greenhouse gas emission from agriculture, including in this case land use change sector in Germany, there we see that about 1/3 of the total emission from these sectors comes from nitrous oxide emission. And again here, fertilized soils are the main source. So all in all, N2O from agriculture is a key category of greenhouse gas emission in Germany. And moreover, it is a main factor of uncertainty in the German greenhouse gas reporting. Therefore, we have the feelings that we need more specific information on N2O emission under German production conditions. So how do we report our N2O emissions in Germany? Up to last year, we used, as probably most countries do, the IPCC 2006 emission factor for direct N2O emissions, which is 1% of the applied N is emitted as nitrous oxide. Probably you all know that in 2019, IPCC published a refinement of this guidelines to report direct N2O emissions. And within this refinement, you have two possibilities. You can use an aggregated emission factor, which also is 1% of N additions from synthetic fertilizer, manure, crop residues, and so on. Or what IPCC strongly recommend to use a disaggregated emission factor, which then differentiate between inputs of nitrogen with synthetic fertilizer and input of nitrogen with organic fertilizers. So for wet climates, they recommend an emission factor for synthetic fertilizers of 1.6% of added N lost as N2O, and for manure or slurry and so on, a lower emission factor of 0.6% of the added N. So we had the feeling that this refinement is not really appropriate for production conditions in Germany, and therefore our objective was to derive specific stratified N2O emission factors for Germany. And how we did this, we conducted a meta-analysis of N2O field studies conducted in Germany. So the first step of improving our inventory was a data collection exercise, and we collected N2O field data in Germany based on the database of the IPCC 2019 refinement. So we found 23 studies conducted in Germany, and we did a comprehensive literature review using Web of Science and Google Scholar, where we just filtered according to N2O emission in Germany. And then we used several exclusion criteria to really filter the valuable studies. So we excluded lab experiments, we excluded studies on pasture excrements and slow release fertilizers because they are very specific and have different emission factors. We excluded natural ecosystems because we focused on fertilized agricultural land. We excluded legume cropping because information on N input is highly unsure in these cases. And we excluded short-term measurements of less than 150 days. All in all, we came up with 71 studies, field studies conducted in Germany at 43 locations. And all in all, we had in the end 676 data points. Each data point was a mean of a treatment of a specific study. And then we divided this 676 data points into studies conducted on mineral soils and studies conducted on organic soils, because we had the hypothesis that N2O emission factor may differ depending on the soil you look, and it is well known that N2O emission is also affected by carbon availability, so we expected higher emission factors for organic soils. If you look at the map of Germany, you see this on the left-hand side. You see with red dots the sites where we had good data for mineral soil, and in black, these are the sites where we have measurements on organic soils. And you see different colors in these maps, and these colors represent different environmental zones according to the classification of Metzger et al. 2015. And this classification includes climate, so temperature, annual temperature, precipitation, but also geomorphology and the distance to the sea, so sea effects, and also substrate, main substrates in different regions. So we can differentiate here in Germany, Atlantic Central area, Atlantic North, and more continental regions in the northern and southern part of Germany. At the right-hand side, you see the years the studies were published. And that's interesting because N2O emission research history is about 30 years in Germany. So many different studies were included in this meta-analysis. And in the lower part, you see the length of the experiments included in this meta-analysis. And here you can see that most of the studies have the duration of 1 year, but we included also some studies with shorter length of the experiment. and then we added this factor, length of the experiment, to our models to, in the end, standardize to 1 year and can compare studies of different lengths. So with this database, we started to model separately for mineral soils and organic soils, and we used the approach already published by Baumann in 1996. We tried to model N2O emission as a linear function of N application rates. That has many advantages with respect to reporting in the end. We used a generalized linear mixed model with gamma distribution to account for varying levels of skewness of N2O emission data. And the mixed effect model approach was used to account for correlations within location clusters and within measurement years. Then the Bayesian modeling approach with prior and post-prior probability distribution was used to compare different models. So we used the data set I've shown you to test different models, and these models differ with respect to potential predictors that were part of the model. For example, the predictors N input and duration of the experiment, or then we tested another model N input duration of the experiment and fertilizer type. In another run, we tested N input duration and environmental zone, as you have seen with the different colored areas in Germany. And then we tested the goodness of the fit and predictive power by RMSE fit and RMSE cross-validation indicators. So the best model, the best fit was obtained for mineral soils if we include the predictors N input, duration of measurement, and the environmental zone, which is a kind of integrating indicator for climate, soil conditions, geomorphology of the zone. And if we run this model, we came up with emission factors for these different zones. And these emission factors of direct N2O emissions vary between 0.4 and 0.9% of the added N. So they were lower as compared to the proposed emission factor by IPCC. And interesting, we found no evidence that emission factors of synthetic fertilizers and manure differ for the German conditions. For organic soils, where we had less data sets, we just used N input and duration of measurement as predictors. And here we saw mean emission factor of 1% of the amount of N added lost as N2O. Please keep in mind, this do not include emissions for mineralization of peat. This has to be determined separately and then added to the value, to the emission induced by fertilizer addition. But the data show and suggests that N2O emission per unit N input is higher for organic soils than for mineral soils, so which is in line with our hypothesis. Then for the first time, we applied these new emission factors to the district scale of Germany. In Germany, we have about 300 different districts. And the first step to apply these new factors was to calculate total N input in this districts, at district scale. N input from synthetic N fertilizers, from manure, from digestates, from sludge, from crop residues. We excluded in this case N from pasture excrements because these were not included in our analysis, and we excluded N input from soil organic matter decrease. So the first figure on the left-hand side shows you the total N input per district, and it's clear to see that we have much higher N input in the northern part of Germany, which is closely related to the intensity of livestock and pig and poultry production in these areas. In the middle, you see the mean N2O emission factor given as percent of the added N, again at a district scale. So it's a mean emission factor for all inputs we had at the district level. And these emission factors vary between 0.4 and 0.9% of the added N. And here it's very obvious that the southern part has higher emission factors related to the N input. And this is mainly due to the climatic conditions. So we have more rainfall, more heavy rainfall events. We have differences in temperature with relatively strong negative degrees during winter time and freezing thawing events. And we have soils which are relatively heavily textured in this region, resulting in higher N2O emissions per unit and applied. And on the right-hand side, you see in the end the results, the mean N2O emission per hectare, also at the district scale. And there it's good to see that we have a hotspot more in the southern part of Germany and in the northwestern part of Germany. In the northwestern part, it's mainly the intensity of livestock production and the input of organic fertilizers. Also, the occurrence of organic soil is relatively high in these districts. And in the southern part, it's mainly the climate conditions and soil conditions of this specific southern environmental zone, leading to relatively high N2O emissions per hectare, which varies between less than 0.5 kilogram per hectare N2O to a mean value at the district level of about 3.6 kilogram N2O. So let me conclude. On average, 0.6% of the N applied in Germany with different kind of fertilizers is emitted as N2O. So this is a new implied N2O emission factor for Germany for direct N2O emissions. Comparing this factor with the IPCC 2019 factor of 1%, you see that our specific factor is now lower, but in the range of uncertainty given by IPCC 2019, and our range of uncertainty is not as large. So we are pretty sure that we could increase the accuracy of our prediction of N2O emission in Germany. There was no evidence for a significant effect of fertilizer type, synthetic fertilizer versus manure on our N2O emission factor in Germany. So that's also different to the IPCC refinement. The model, including interactions of N input in environmental zones, showed the best performance, and that's the new basis for our N2O emission reporting in Germany. So if you consider to develop specific N2O emission factors for your country, you should keep in mind several key points. First of all, you need representative data on N2O emission. So networking with neighboring countries probably really helps. You need reliable activity data back to 1990. Most important are the N inputs here. Data on most important predictors influencing emission rates, such as climate, soil conditions in your country. And it's really helpful, I hope, to have a peer-reviewed publication, as Joel already mentioned, to get it through the inventory report and the evaluation of your inventory. So thanks for your attention, and I'm happy to take questions if there's enough time.
Heinz, thank you very much. Looking at the time, I would like to invite the next speaker, but we will have questions for you. I also have some questions if there's time, but I will let the other people ask questions first. So with that, I would like to introduce Carlos Alfredo Gomez Bravo. He is a principal professor at the University, National Agrarian University La Molina in Peru. He has been a professor and researcher at the Faculty of Zootechnics of the university since 1980. He's specializing in sustainable livestock production, ruminant nutrition. He has worked closely with Peru's National Inventory team for several cycles, both contributing to accounting and leading research projects to improve Peru's inventory estimates. Carlos has also directed and contributed as a researcher to several development projects related to livestock production in coordination with different institutions such as the International Atomic Energy Agency, the FAO, the Swiss Federal Institute of Technology, Zurich, International Potato Center, the International Livestock Research Institute, and the World Bank. Carlos is currently the coordinator for Peru of the International Comparison Fund, IFCN. And with that, I would like to invite him to present today on commissioning and managing agricultural inventory research projects, perspectives in Peru. Do we see the
Hello.
presentation, Carlos? Yes.
Claudia, is
Can
that
you
view strange? It looks strange to me.
What looks strange?
The slides,
presentation?
yeah,
It's good. It looks good here.
okay.
Hello,
Hello?
good afternoon. Hello.
Yes,
you
hello. Here.
Yeah. Please, Hazel. Hello. Okay. The objective of the presentation is to describe in Peru the process of designing research to meet inventory needs, of course, contributing to the improvement of them. Just as a context, Peru has produced 6 inventories already. The Ministry of the Environment is the one that receives, reviews, and consolidates information from the different sectors. We are in the context of the agricultural sector. So in my country, the Ministry of Agriculture is in charge of providing the information that is being received by the Ministry of the Environment in order to get the final report. Next one. Next one, please. The next, okay. Just as a context as well, agriculture in Peru, or the AFOLU sector, represents 65% of total emissions. And on the
Seems
AFOLU sector, agriculture is
Hi, Carlos. We're just struggling with the connection a little bit.
okay. Entonces, agriculture represents 20% of the AFOLU sector. And in the next slide, we are going to see that enteric methane emission is the main component of the agricultural sector, followed by the nitrous oxide emission from the soil, both the direct and indirect emissions. As you see there, 55% of the total emission for the agricultural sector corresponds to enteric methane fermentation. Next one, please. As you know, the IPCC guidelines explain that the emission from a source is calculated activity data times emission factor. So from our standpoint, research could be associated to any of those 2 components. Next one, please. As I indicated, the Ministry of the Environment leads the inventory efforts. As a consequence, it identifies, in coordination with the specific sector, which are the gaps in the process that require support of research for improvements. I am a researcher, so different to the 3 prior speakers, we were more related to commissioning or reviewing research in order to improve inventories. I'm in the other side of the business. I am researcher who gets commissions from as I indicated, the Minister of the Environment leads the effort in coordination with the sector, identifies the gaps that requires research. One comment that I could do at this time is that there is limited expertise for identification, for example, of the cost benefit of different research options that could contribute to improvement of inventories. So that's the first step, we need to identify what are the research needs. And in my consideration, we should prioritize them. That's the effort of the environment minister in coordination with the sectors. For example, will we give resources to improve enteric methane or nitrous oxide from the soil? Or should we prioritize research on activity data or in emission factors? I feel that that's a need to have more work in order to have expertise to identify them, which to prioritize. Next one. Already identified for the agricultural sector, it can be conducted in my country either by the staff of the Ministry of Agriculture, including the National Research Institute, and or staff of the universities. Those are the two options to get the research commissions in order to improve inventories. Next one. For example, the actual methodology for the agricultural sector, as you can see, most of them are in the tier 1 methodological level. Only in the last 2 reports, enteric methane for cattle have gone to the tier 2 approach, and all other animals are in the tier 1 methodological level. And I need to add also that the tier 2 is based mainly expert opinion and statistics. So given that reality, next one, I'm putting as an example of commissioned research. Being that reality, it was identified a gap or a need, the improvement in the precision and accuracy of that emission factor for enteric methane using the true methodology tier 2. As you can see, the true methodology tier 2 requires data like gross energy intake or an approximation to YM. In this case, this is an example of commissioned research led by the Minister of the Environment in consultation with the Agricultural Minister and being contracted and university in order to improve the emission factor accuracy and precision based on a change from expert opinion and statistics to real true evaluation using the needed information. Next one. Another aspect of this activity is the search for funding. In this case, always there is the possibility of the national funding and or cooperation sources. For the example that I described, the Minister of the Environment proposed to UNDP having that research in the framework of a more larger integral project for improvement of transparencies of inventories. Having been approved by UNDP based on the request of the Peruvian government, it was invited a research group in a university to conduct that project. This because the staff of the Ministry of Agriculture have limited expertise for that activity, neither have the time. Next one. I want to close before share with you that we are initiating a seed project funded by CITED. That's a Spanish organization. That project is named Low Carbon Livestock Research Network. And it is interesting that the objective aligns a lot with the webinar today, that is contribute to the improvement in the quantification of emission of gases and the inventory of the livestock sector in participating countries, 7 from South America and 1 from Spain. The timing for this project is 2022 to 2024. This is a seed project. We hope that by the sharing of information using this project, we could have better activities later on. Next one. As a take-home message, the first one, staff at the responsible institutions, in this case, Minister of the Environment and Minister of Agriculture, will benefit from improving their expertise in relation to the identification and prioritization of gaps in inventory that will be supported by research. The second take-home message that I could share with you is that universities or research institutions should develop expertise to conduct research that could support improvement of inventories. Both relate to capacity building, and I could say that that is a good investment in general for improving inventories. Thank you very much.
Thank you very much, Carlos, for the very interesting presentation as well. Now, we're already well in time. We only have 22 minutes left, but I still would like to go back to the questions that we have in the question and answers to give the opportunity for them to be answered. So I would like to go first to Prof. Ray's question, which was for the first speaker, for Joel. We're doing research to establish enteric emission factors in cattle, local breeds, under local grazing conditions in Uganda for Tier 2. What would be the requirement for the emission factor to be recognized? So that was for Joel.
Oh, this is a tough question. I guess it would depend on the circumstances of what kind of the quality of the data that you're gathering. Yeah, what kind of detail is available. I think in terms of the specific emission factor, in terms of enteric fermentation, it may be best just to stick with the IPCC values in this case. The bigger improvements in terms of the development of that Tier 2 method would be in understanding more about the feed requirements and understanding the production data, and also the quality of the feed that is being used. That's where I think the improvements would be best placed to come from. So understanding the feed requirements, and which requires getting good data on the production and weight of those animals, and also the types of feeds that are used and the quality of those feeds in terms of energy content. Hopefully that answers your question.
I don't know if you can maybe indicate it in the chat, since you can't ask directly. So just to reiterate what you're saying, so it would be mostly in activity data collection, especially on the feed side, where improvements could be made from your perspective.
Yeah, that's where I think the better value is. I mean, developing the emission factors for enteric fermentation in terms of cattle, depending on the instruments used, can be quite expensive. And I think the better use of resource, and at least initially, is definitely in terms of the activity data side of things, and in terms of calculating the energy requirements more accurately.
And just from my experience, it would be basically for the different cattle systems, or for the systems that they say that they have most emissions from, or are great ecological zones. Okay. There's one more question for you, I think, from Maggie. Must data or research studies only come from the country that developed the inventory? So it's basically, I guess, for France, could they use the nitrous oxide emission factors that Heinz has developed in Germany?
Yeah, this might be a question better answered by Heinz or someone else. Given New Zealand is thousands of kilometers away from any other country, we're not probably the best place to answer this. Yeah, I guess, I mean, things to take into account are things like, soil types, whether they're similar, climate, or, proximity. I mean, if those things are relatively similar, I mean, it could definitely make sense to utilize research done in other countries, assuming that they're, in comparable situations. But yeah, maybe I'll leave it to some other people to answer or comment on.
Heinz, do you want to comment?
Well, you're completely right, and I have nothing to add. Now we have a really good database showing not only N2O emissions, but also environmental condition, which fertilizer was used, how much was fertilized, which crop, and if the conditions are comparable to the conditions we published or we collected in our database, then I would expect that also France could use this study.
Okay, thank you very much. This is a question from me from curiosity. Maybe you can answer it quickly. The data set you have, Heinz, is very humongous, and you have so many data points for your emission factors. This is not the context for developing countries. Did you do sensitivity analysis to actually say we do really need all this research studies, or maybe like a lower number would be okay? Because until an African country is going to anywhere close to what you just showed to Germany, like we're probably in 2040 probably, or something,
My feeling is that starting with a more specific measurement design, it would be probably possible to get good results with a lower number of studies. So, as it was mentioned in the chat, many of these studies we used were not designed to derive emission factors, in particular the older studies. Within the last 10 years, we have many studies which really try to develop emission factors for specific situations, specific crops or fertilizer types. But at the beginning, this was not the main question. So if we start with a measurement program in developing countries, we should design it very detailed, where we should measure, which situation, covering a representative net of climate data, soil data, crops, fertilization, and then we will probably get good results with a lower number of studies.
Okay, thank you very much. With that, actually, I would like to get to Samuel's question, but I give it to all panelists. If you have experience with not meet the research timeline, could you share experience how this challenge was addressed? So I guess maybe the ambition of a research project would have been too big, or maybe funding just doesn't get us all the data we need. Like, because there's limited funding from I'm trying to interpret Samuel's question here. And if there is anywhere where we could address if we have an unfinished study, because of time, because maybe things didn't go smoothly and the project didn't get an extension. And then we may just be left with unfinished research. I don't know if there's a question, like an answer to that, because this is complicated, I guess. Anybody wants to comment on that? Sana.
Okay, because as I showed in my slides, for example, Mongolia has like a 30 million sheep and 26 million goats, but during the project time, it was only about 200 animals measured from the 3 provinces. But we have the 21 provinces and at least 3 types of natural zones were quite different. But the project, and then this pandemic is, and then every province border is closed. So it's about the timelining is cannot catch could not continue during the framework of the project time. And then how it addressed those weight measurement, and then the other like milk production and other parameters is based on previously made researchers somehow. But definitely in the future, I hope it will be continued and compiled and more enough sample size to can represent the total population of the livestock in the country. Okay.
Okay, thank you. So you're hoping for a follow-up project to make use of the data, yeah? Okay. I have now a very long question from Roland Gröbel. Having used a similar approach, and this is for Heinz, I think, yes, because nitrous oxide. So please listen. Having used a similar approach in Canada in 2008, and for an updated version in 2020, the question arose from the process. The meta-analysis appears to have the weakness that it is reactive, looking back at what was measured, often using experiments that were not designed for the purpose of developing emission factors, and often dismissing details due to lack of replication. However, with the nitrous oxide emission reduction targets, new application methods and new types of fertilizers will need to be considered. The question is thus, how many measurements are ideally statistically needed to development of a new emission factor, sites, years, replicates, in order to avoid weaknesses, biases, and oversights? Did you make good note, Heinz?
Thanks for this question. I know the study from Canada. Great work. Congratulations. That's really nice. Yeah, you are right. The first studies we used for our data analysis were not designed for the purpose of emission factor development. Nevertheless, they were really helpful and useful to complete the whole data set. So how many studies and data sets you need, this really depends on the variability of your production systems. So what do you think of crop effects? Have you really different emission from different crops? Which type of fertilizer do you apply? Have you very wet and dry climates, hot and cold climates in your country? So there's no one number solution for this question, I would say. And you should test the range of your emission factor you get in the end. Is it better or is it worse as the IPCC range, uncertainty range given? And this range will give you an indicator how your accuracy is in the end and how good your estimates are. We all have to report on the degree of uncertainty in our reporting systems. So they will see how good in the end your N2O estimates are. But there's no single answer to your question, I think, because it depends as always.
All right, thank you. I do have more questions for you, Heinz. Your presentation did raise a lot of questions here, I think. So this is from Samuel Anuga again. I'm curious, nitrous oxide was reported, if it was reported in hectares, which means per unit of area. If it was quantified per unit of product, would it have had different policy implication or influence the emission factors generated?
Yeah, normally we do both. We calculate it as a hectare on a hectare basis to be in line with the reporting system, because in the end, the emissions reported are emissions from the surface of Germany. So that's a surface-related indicator. But if you develop mitigation options, then you really need the yield, and you have also to relate the emissions to your yield. Because the yield-related emission is one of the most important indicator to get, in the end, less emissions, but keep yields high. So you need both. But our reporting system actually is based on the national scale, which is an area base. But I fully agree that we, in the end, need both indicators for a good policy.
Okay, thank you. I'm getting more questions here and I'm looking at the time. So I go in order and stay with you, Heinz, for now, and then I have another question for Carlos. The N2O emission factors for animal excrements and grass clover swards were not considered in the analysis. Were these sources considered in estimating the uncertainty figures? No, you didn't include, like the maps you showed did not include any of these emissions, did they? I think that's the question.
We included different types of crops and also grasslands, and I'm sure there were also grass-lay systems, because we had a large program on the effects of growing grass-lay systems. So I think they are included, but I have not shown specific uncertainty ranges for specific crops.
Okay, thank you. So the last question right now, for now, for Carlos from Nidshashe. I'm so sorry, Shirinda. I hope it's halfway acceptable, my pronunciation here. Are there any plans to move to tier 3 in Peru? Is the livestock sector the lowest hanging fruit? Is the work on the other subsectors that is in tier 1 as shown in the table? So the question is basically, will you look at other ones, and maybe there are other low-hanging fruits, because maybe in TERIC you can't do as much mitigation. Carlos, are you still there?
Yeah. No, there is not plans to go to tier 3 methodology. We are struggling now to have tier 2 for the enteric methane of cattle, and the next state will be to go to the other livestock species. The main one is sheep. From the standpoint of the other agricultural emissions like nitrous oxide, in my country is so widespread, the production systems and the crops, that it is really hard work to have that, because there is not a predominant crop that will be, like in the case of cattle, majority of the emissions. That would be my answer at this time.
Okay, thank you very much, Carlos. We only have 4 minutes left, and I would like to discuss the challenge that a lot of times developing countries face, that they don't have money to go up to tier 2 inventory. And if there's other research or commission inventory research, so that to get more creative in doing that. So I was wondering how Peru, because you've been working on this for a long time, how Peru has managed to actually work on livestock, and also Sana from her, where the funding came from to actually move from tier 1 to tier 2 emission factors for some of the species, and how Peru went about, and how we can do other developing countries.
Clarify a little bit better the question, please, Claudia.
Oh, the question is how, so Peru, the money, where did the money come from that Peru used for the commissioning of tier 2 emission factors and the research that you were doing? And I would like to ask the same question to Sana to give a better idea to developing countries, how they can go about improving their inventories.
Okay.
This is
in our case, as I indicated, the funding is coming from UNDP sources. From the national budget, it is restricted only to the standard methodology for inventories. When we want to improve, like tier 2, the standard thing is to look for international funding cooperation, and that is the status at present. I mean, that would be my answer in the case of Peru.
Okay. Okay.
Yeah.
I will be brief. So first, to improve the check the activity data. How much is your country possible to disaggregate the activity data, and then consider the emission factor. And that's all I want to say. Because to make research too much research, and then without the disaggregated activity data, it's also meaningless. Also, that's okay, because I'm seeing the time and a little bit rushing.
No, it's okay. If you have like another, you can take a second, and then Carlos wanted to say something quickly, and then we're going to wrap up, and I think I give Hazel then the floor to wrap up again. But if you have anything else, so it's activity data first, make sure that's okay before you work specifically on the emission factors.
And also the Paris Agreement and ETF transparency, it's recommending that avoiding the backslide. So once we shifted the developing country to the tier 2, its next submission is difficult to back to the tier 1. So very careful consideration and continuous basis the availability of the studies in the next submission. So this is also should be very carefully considered.
Okay, thank you. Thank you very much for your expertise there in this area. Carlos, quick.
Yeah, I want to also say the same like in the last intervention. I mean, activity data requires less budget than improving emission factors, and at least in my country, the statistics official of number of animals and so on is not as helpful to give the numbers for activity data. And I would say that's an avenue that I haven't seen much doing research, and that's, at least in our case, in a next project, we are going to push activity data better obtaining information to produce some kind of format or templates so the government can do later on standard gearing of information about activity data. Thank you.
Yeah, I do think this is a very important point. Thank you very much, because I know this is in need of all the countries. With that, I want to thank everybody. We're 2 minutes over time who was here, and thank you very much for your interesting presentations and all the knowledge you've been providing us to improve inventories. And I want to give Hazel the floor for actually for the announcement of the next seminar, maybe. So you get a quick preview.
Hi, everyone. Yeah, just to say thank you. No announcement of the next seminar at this stage, but thanks everyone for participating. I think it's just been really good to have these 3 sessions and discuss some of the issues that are common but different across developing countries and developed countries, like activity data being kind of a key issue no matter what stage of development, and also communicating with researchers what's actually needed from research projects and when you put it into an inventory context, and finally kind of utilizing the research results to actually end up in improvements to the inventory, whether that be higher estimates or lower estimates of emissions. So yeah, thanks so much, Claudia, for chairing this session, and thanks to all of the participants and speakers. Very much appreciate you sharing your experience and perspectives. Thanks, everyone. Bye.
Thank you. Bye-bye.
Bye. Thank you, everybody.